Greetings, Mr. Sutton here with the AB Calculus 3.5 Extra Practice Number 4 solutions on product and quotient rules. For this problem, we're trying to figure out the derivative using a product or quotient rule. We've got a product here, so we will just use the product rule. That's u prime v plus uv prime. And now for my box and ribbon to organize things, I've got the first parentheses of stuff in the upper left here. In the upper right, I'll put the 3x squared plus 2. And now I'll put their derivatives down below. So that's negative 5x to the fourth plus 6x squared. And for this one, we've got 6x. Using the ribbon to put it all together now, we've got this stuff in the lower left times 3x squared plus 2, parentheses for both of those, plus all this stuff in the upper left times 6x. And they said no need to simplify, so we'll just leave it like that. On this problem, we're trying to figure out the derivative of this function. Now, they didn't specify which method to use, so you could theoretically try simplifying this, only you'll find that you can't factor the numerator at all. So it's really going to be quotient rule or nothing on this one. So our quotient rule then, I'm just going to write out the formula. That's u prime v minus uv prime over v squared. And now let me set up a box and ribbon to organize everything here. So in the upper left, I've got my numerator, x squared minus 4x minus 2. In the upper right, my denominator, x squared minus 1. And now their derivatives down below, we've got u prime and v prime down here. So for u prime, we've got 2x minus 4. For v prime, this will be 2x. Using the ribbon to put it all together, we've got 2x minus 4 times x squared minus 1. That's u prime v. Minus all this stuff in the upper left times 2x. That'll be uv prime. All of that over v squared, so that's going to be x squared minus 1 squared. And they said no need to simplify, so this is as good as it needs to be. On this one, I'm given a graph of f, and the g function is given by this weird function here. We want to know the value based off of this of g prime of 2. Now, since g is a quotient and there's no way to really simplify this, I'm going to have to use the quotient rule, u prime v minus uv prime over v squared. Let me set up a box and ribbon to represent the g prime function here. So up top, I've got u and v. In this case, that's going to be x squared plus 1, the numerator in the g function. And v is going to be the denominator, so just f of x, which is represented graphically here. And now down below, I've got u prime and v prime. So derivative of x squared plus 1 is 2x. Derivative of f is, of course, f prime. Can't really say much beyond that at this point. And to figure out what g prime of 2 is, I'm going to plug 2 in for x in each of these expressions. And then I'll put everything together according to this general structure here. So still in the box, now I'm plugging 2 in for x. X squared plus 1, that's now 2 squared plus 1, which is 5. This is now f of 2, which I have to look up in the graph. So at the x value 2, my graph is giving me a y value of 3 for that spot. And now 2x, that's 2 times 2, which is 4. F prime of 2, that's the slope in the graph at 2. So again, at x equals 2 at this spot here. Now I'm looking at the slope, and it looks like we're going, let's see, up 4 over 1. So that's a slope of 4. Now I multiply all this out to get g prime of 2 in that fraction there. So I've got u prime v, that's 4 times 3, and I'm using the ribbon sort of motion here. 4 times 3, which is 12, minus 5 times 4, so minus 20, all over 3 squared, so over 9. So we've got, let's see here, negative 8 ninths then, which is going to give me answer choice A. For this one, I've got a table of values for f and g and their derivatives at x equals 2. If h is f prime of x over g of x, ooh, that's kind of interesting. Usually it's just f of x, but now it's f prime of x. We want to know the value of h prime of 2. Okay, so h is a quotient. There's no way to simplify this. We're going to have to use quotient rule. So that's u prime v minus uv prime over v squared. And let me use the box and ribbon to help me keep things organized. So for u and v, that's the numerator and denominator. So I've got f prime, that's the numerator in this fraction. G is my denominator. And their derivatives, this is kind of the easy part of the problem. The derivative of f prime is f double prime. G becomes g prime. And now if I plug 2 into all of this, which I'm going to do inside the box, I might as well before I start putting things in a big gnarly fraction. If x equals 2, f prime of 2, looking that up in the table here, that's just going to be -3. Now we need g of 2, which in the table is -2. And now we need f double prime of 2, which conveniently they gave us that also. That's +3. And then finally, g prime of 2 is right here. That's 5. So putting all this together to get h prime of 2, we're going to have 3 times -2, or -6 eventually. Then we subtract -3 times 5. Finally, dividing by v squared, so that's -2 squared. So we have -6, and this is going to be plus 15, so that's overall 9 in the numerator, over 4. And is that one of the answer choices? It is, choice A. For this problem, we're given a table of values for differentiable functions f and g and their derivatives at x equals 4. We want the value of the derivative of f times g at x equals 4. So because we have a product and we can't really simplify it, we're going to have to use the product rule, u prime v plus uv prime. That's what, I'm just going to call this h of x, but I guess you could call it whatever you wanted. And let's use the box and ribbon to sort of organize things as we're doing this. So I've got my original two factors, f of x and g of x up here, and their derivatives down below, so f prime of x and g prime of x. And I'm just going to use a ribbon sort of formation to multiply them together. But before I do that, let me actually plug 4 into everything just inside the box here. So f of 4 in the table, that's going to be 2. And then g of 4, going back to the table, that's going to be 3. F prime of 4 in the lower left, that's 7. And then g prime is going to be 5. We're going to put that down in the lower right here. So using the ribbon to multiply this out, we can say that h prime of 4 is going to be 7 times 3, that's 21, plus 2 times 5, so plus 10, adding up to a grand total, to simplify it for the multiple choice here, of 31. So that's going to be choice C. For this problem, we're trying to find f prime of -1, given the f function here. So in order to take this derivative, I'm going to have to use the quotient rule, u prime v minus uv prime over v squared. And that's because this is a quotient and there's no way to simplify it. So let me use the box and ribbon to organize things. I've got my numerator, 2x squared minus 1 going up here. And up here is my denominator, 5x plus 3. Down below are their derivatives, which are 4x and 5. And before I multiply things out and put it back together, I'm actually going to plug this -1 in inside the box. So, if x equals -1, what do each of these things equal? 2x squared minus 1, well that's 2 times -1 squared minus 1. That's just 2 minus 1, which is 1. And then this is 5 times -1 plus 3. That's going to be -5 plus 3, which is -2. 4 times -1 is -4. And 5 is a constant, so we just bring it down. Multiplying this back out now using the ribbon, I have -4 times -2 minus 1 times 5. That's uv prime we just did there. And now the v squared we're dividing by -2 squared. Now this, of course, doesn't match any of the answer choices just yet, so I'm going to have to take a moment to simplify this a little bit. In the numerator, we have 8 minus 5, which is 3. Denominator, this comes out to +4. So that gives me answer choice C. On this problem, I'm given the functions f and g in graph form, and I'm told that another function, h of x, is really f of x plus 4 over g of x plus 2x. Based off of this, I want to know h prime of 3. So because h is a quotient and I can't really simplify it, for h prime I'm going to need to use the quotient rule, u prime v minus uv prime over v squared. And let me set up my box and ribbon to help me with this. So in the upper left, I've got my numerator, f of x plus 4. In the upper right, denominator, g of x plus 2x. And now their derivatives go down below here. So this is just f prime. 4 is a constant, so we zero that out. And then down here we're going to have g prime plus 2, because we had 2x initially. Okay, so before I multiply everything out, I'm actually going to plug 3 in inside the box here. So let's see what each of these corners should be if x is 3. So let's start with f of x plus 4. That's f of 3 plus 4. Well, looking at the f graph here, the x value 3 gives me an output of 4. So this is really 4 plus 4, which is 8. Next, I'm going to do g of 3 plus 2 times 3. So g of 3, looking that up in the graph, g of 3 it looks like is 2. So I'm doing 2 plus 2 times 3. That's 2 plus 6, which also happens to be 8. Down below here now, this is f prime of 3. Going back to the f graph, the slope at x equals 3 looks to be about 1/2. So we'll put that down there. And now we're doing g prime of 3 plus 2. Well, g prime of 3, looking at that graph, we have a slope of negative 3 going through there, but we're adding 2 right here. So this actually comes out then to negative 1. All right, multiplying all this out using the ribbon, I've got 1/2 times 8. And let me just write out h prime equals big fraction here. So 1/2 times 8 minus 8 times negative 1, all over v squared, so over 8 squared. Simplifying this a bit, this is really 4 plus 8, which is 12. And then 8 squared is 64. So I can reduce that by 4 to be 3 over 16, giving me answer choice C. For this one, we're asking for the slope of the line tangent to this graph at x equals 1. So basically, we want to figure out what y prime is and then plug 1 into it. Now, since it's impossible to simplify this thing and use the power rule, we're going to have to use the quotient rule on it. That's u prime v minus uv prime over v squared. Let me set up the box and ribbon to help me with this now. So I have my numerator, 9x squared. Denominator is x plus 2. That goes in the upper right. And down below, we've got u prime and v prime. So this is going to be the derivative of 9x squared down here, 18x. Derivative of x plus 2 down here is going to be just 1. And I could multiply this out, but let me plug 1 in inside the box, and then I'll multiply stuff out. So 9x squared then becomes just 9 times 1 squared, or just 9. X plus 2, that's now going to be 1 plus 2, which is 3. This is 18 times 1, which is 18, and 1 is a constant, so it's still 1. Multiplying this out, this is y prime of 1 here. We're going to have 18 times 3 minus 9 times 1, all over 3 squared. And I have to simplify that to match an answer choice. So I've got, let's see here, 54 minus 9 is 45. And then down here, this is 3 squared, so that's 9. 45 over 9 gives us 5, giving me answer choice B.